Okay, it's a bit cold in the UK, but I'll do this just for FWG and Rob. Still supporting, mate, still there. Oh, I will be buying some ink off Rob, actually. I do normally make my own inks and stuff like that, but I've got none left and I don't want to make any more. So what better than, you know, buy some from FWG and, you know, sponsor this. So I'm going to be doing that. It's to make up a load of microwave kilns, and I mean a lot, because I want to use one particular kiln for one particular job, or a particular activation or whatever, and you know, that's why I want quite a, and I'm talking about 25, you know, maybe 30, so that's all in aid of. Now, I did also say that my next video was going to be a compilation, but I haven't got round to it yet. I'm sort of a third of the way through that, and the reason is it's a long-winded thing because I've got so much old video to trawl through, you know, so it's going to take a while, but I will do that video. There's too much useful information to just delete. So anyway, this particular video is a bit of a change of tack for me because I'm playing with electrolyte. We all know the choline chloride does a job, and you know, it shouldn't work as well as it does as an electrolyte, but it does. But I've had to play with some zinc sulphate, and there's a twist to that as well, which comes in at the end of the video. It was a bit of a mistake, and it gave me this new chemistry, and what chemistry it is, it's phenomenal, pretty phenomenal. I've still got the battery on the bench and it's on charge now, and this is like 5 days later, so I was loath to pull it apart and have a little look at it and see, you know, what the internals are like. It's still charging up, it's still discharging, it just keeps going through these cycles, and it's zinc. So dendrite wise, nothing yet, so that's that. It's the usual setup on the anode cathode carbons, as in my last few videos, so I'm not going to run through that again. Have a little look at this one. The results are pretty good. So I'll leave it at that. Okay, there's some stuff going on at the moment. That's a battery there. It's a paper battery. As you can see, there's a piece of glass on top as the tool to put the squared pressure on the two graphite plates there. I'm just using the graphite plates for convenience at the moment. They are nice and microporous, as we know, and this is the same size as that old paper battery that you've seen before. If I get another piece of this glass, there it is. Okay, so that's the same size, that's what's on there, and that's the same style of paper battery with activated carbon on the anode, and cathode is carbon fibre, milled carbon fibre. What did I put on this one now? Let me just put that there for a second. Wobbling all over the place. Yeah, a bit of garlic carbon for sulfur grouping, milled carbon fibre, and I did put a little bit of graphite on there as well. And the last component, I can never remember this one, and I should. Manganese dioxide, of course. I don't know why I always struggle to remember that one. It's one of the most widely used components that there is. But anyway, 50 milliamps there, constant current. It's turning into a battery curve at the moment. 0.7 of a volt left. We're almost on 29 minutes. Now, the significance of this is that I'm trying out a new blend of electrolyte, and the base is choline chloride again, as kind of an ionic liquid, if you like. There's no glycols in there at all, either mono or polyethylene glycols, nothing like that. It's got 25% water, so it's 25% aqueous, which I've said this before. This is what I'm using now, and basically I've added some zinc sulphate. So I'm just looking at this chemistry and see, well, just to see what happens and where we go with it. Basically, it seems as though it's working well, but of course it's a first attempt, so you know, what can we expect? Well, we're on half an hour so far, which I think is pretty good for that, again, that size of paper battery, at 50 milliamps. I've yet to try it at 100 milliamps, so this is its second charge cycle. The first charge I just charged it up for a couple of minutes just to see if it was going to work and hold some voltage, and it did. And this is the result of the second charge. So we've got some other ions zipping around. We've got some sulphate ions this time. I haven't really even looked at or considered what sort of a half reaction we've got on this one, so I will look at that later on. Basically it was a just try it and see moment, you know. So and this is the result. But obviously you have to sit down and look at the reactions in the chemistry and work out what well, the choline and the chloride ions are doing, and the zinc and the sulphate ions are doing. It's all got to be looked at, so I'm guessing that's next. But for now I'm enjoying this, so I'll come back when it's nearer the end. Okay, back in, almost ready to stop, and there we go, all stop. 35 minutes, quite happy with that. What I'll do is I'll just stick around for a couple of minutes and look at the recovery, and then put this thing back on charge. Intriguing. Right, back again. I'm going to clear that curve there, which was 35 minutes, as we can see, at 50 milliamps. I'm just going to give this a second run, charging at 3.2 volts. It's not really charged, but hey ho. What I'm going to do is press start at 2.4 volts. I'll just monitor the start for a minute. Okay, not bad. Not a bad start. I'll come back at some later time. Okay, quarter of an hour in. We've still got 1.6 volts left. 50 milliamp constant current load. Curve's looking good. Yeah, I'm quite liking this actually. Let's see where it ends up this time. I'll be back. Well, obviously I've been watching this for a while now, and it was doing so well, I thought I'd leave it for a bit. Still got 0.8 of a volt, and we're on 40 minutes. That's still got that slight hump, but not as pronounced as it used to be. So not quite certain what's going on there yet, but you know, a trait of using that material. That's what I've always said. You know, the milled carbon fibre. So anyhows, there it is. I'm gonna pause the video again and come back shortly. Well, what I thought I would do is let this thing finish and just leave it for a while, 5 or 10 minutes, and see if there was any bounce back, recovery. 50 minutes on that run, wow. To say I'm pleased would be an understatement, because we're not far off the hour, are we? At this stage the energy is only 54 milliwatt hours and capacity is 42 milliamp hours, which is about right really, because we've got, or we had, a 50 milliamp constant current load, so 42 is about right. If that had gone to the hour, then obviously that would have been a 50 milliamp hour capacity rating. So onwards and upwards. I'm going to charge that again. Well, this is charge number 3. 45 minutes so far. Let's see where we get with this. It's not going to go much longer than the last one, even if we get to the target, but something else, this electrolyte. Okay, that was run number 3, or charge number 3, run number 3, 50 minutes again. I've literally charged this thing up again. Not certain what to try next really, but I guess 100 milliamps, double the current. Not certain of what to expect, to be honest. We got that 42 milliamp hours again there. So, well, yeah, I'm guessing we should just try this one really and be done with it. Well, I did click start and it didn't work. We'll click it again. That's more like it. So double the current, 100 milliamps. Okay, I'll let that run. Doesn't look like it's going to be anywhere near half of the time we just had, but we'll see. It never works out like that anyway, so I'll pause the video and come back. Okay, so there we go. 10 minutes in, 1.2 volts left. Same battery. Sorry if you can hear some bubbling in the background. I'm just drying off some new carbon, which is that, and there's the battery. The same battery. Yeah, interesting. 10 minutes in, it's 100 milliamps. Okay, I'll pause that because my battery's low, and I'll come back. Well, I've got to say, 15 minutes in, just under a volt, 100 milliamps. not looking too bad. I think this chemistry is looking quite good. It's the first time really that I've made any sort of addition to the choline chloride regular mix that I've got, or I've used. So I think we need to look at this again. Now I've got to say I used a half molar mix of the zinc sulphate. I'm guessing really we should try a 1 molar and go from there and take it in stages. From memory, this was a 50-50 blend, so that's my regular choline chloride, half molar zinc sulphate. Okay, so 17 minutes in, I'll come back at the end. Well, that's just stopped. 23.5 minutes. Wow. What can I say? Apart from I'm happy, obviously. Didn't expect this, but time to work on this electrolyte, isn't it? Same carbons, better results from the electrolyte. Over and out. Okay, problem time. Well, not such a problem as such, but that discoloration there, I've just realised what that is on this paper battery. I'm going to explain that at the end of this on my outro. It could explain a little bit more about the chemistry, so I'll come back to that in a bit. Over and out. Okay, as I turned everything off last night, this is the following morning. This is back on charge, 3.2 volts, which is the charge voltage I use now. Yes, I did some testing yesterday with 2.3 volts, or charging I should say. But three things that I thought about. One was let's do an upscale. So that will be the upscale today, hopefully. Obviously I can't use graphite as the collectors because I haven't got any graphite that big, so it's going to have to be carbon fibre weave. The other thought was that this was pretty good, and the last thought was, well, I didn't do a short circuit test. It's definitely not fully charged, but what I will do is turn that off and go for the short circuit test, and that is set on 10 amps. Wow, 1.3 amps, and look at that holding. That's incredible. That's unbelievable. That's better than anything I've built before. I had to look at the switches on the chargers to make sure I'd switched off. Okay, so the very last test run on this battery, which is still that paper battery there. We're set at 30 milliamps. Just to do a 30 milliamp run, no particular reason, not interested in energy, capacity or anything like that. It was purely just to see what effect
sulphate would have on the overall chemistry. So and we're already up to 51 minutes there, almost 52, look, and we've still got 1.1 volts left, so it's not doing bad. So this will be the last run, as I say, before I tear this thing apart and start looking at the chemistry again. I need to seriously look at what's going on with this chemistry, so that's what I'm going to do and try and come up with a magical formula, or a formula that works better than this for the same carbons, the same surface area, etc, etc, because that's the name of the game, isn't it? So I'll come back at the end of this one. Okay, I just thought I'd come in at this point. We've got 0.648 of a volt left, 1 hour 23, how about that? Okay, I literally just missed the end of this one, so an hour and a half, about right I guess for 30 milliamps, 50 minutes on 50 milliamps, and I think it was almost half an hour on 100 milliamps, so that's about right. Quite pleased with that. Just for my own purposes, I'm going to charge it one more time and do one last test with it. Whether I show that or not, I don't know. So this is the last test then. Don't know what that was there. 200 milliamps. I guess it just wouldn't be me if I didn't do this, would it? I can't see this lasting very long because I didn't fully charge it again, but I just wanted to see how it would cope with that massive overload, really, as I always do. So we'll let that run. So this is the same battery, same chemistry, and for over 24 minutes it was at 2 volts or above 2 volts. It's just this second drop down below 2 volts by 4 thousandths of a volt. And this is at 10 milliamps. I just wanted to do this one anyway, just to document it really, so I'll come back later on. Okay, here we are, 2 hours and 22 minutes and we've still got 1.18 volts left. Amazing. Yeah, it's only 10 milliamps. That spike there was me. I went and pressed the charge switch for a microsecond or so. Very interesting. Very interesting. I'm just looking at the capacity and the energy ratings at the moment, which is quite meaningless to me at the moment. That, you know, this is all to see how this new electrolyte performs, and it performs exceedingly well. So I'll come back later on. I don't know when, but later on. Well, as expected, 3 hours 10 minutes at the moment. No point in saying a lot more really at this stage. It was just to check in and see what was going on. I'll try and come in at the end and let's see what happens then, because that's an important bit as well. Okay, unfortunately I've just missed the end of that. 3 hours 54 minutes. Not a lot of recovery. Wouldn't expect too much, I don't suppose, after that, but 3 hours 54. What are we reporting? 39 milliamp hour capacity, 52 milliwatt hours energy rating. So that's that then. A battery curve. I've explained what that glitch was there, so yeah, not bad. Not bad. Okay, I was earlier on I was quite intrigued with the short circuit on this battery, because normally what you get is a nice peak and then it tails off quite quickly with a lot of this stuff. But this particular one, it was a bit different. So what I'm going to do, this has been on charge for a bit. I'm going to turn the charger off. This is set on 10 amps. So I'm going to do that. Now 1.33 amps was the peak. And we're still over an amp now. Pretty good. And that's a dead short on the 10 amp scale. We're doing 940 milliamps there. Incredible. Okay, that was about a minute ago. I don't know if this is going to recover and go back up or just remain where it was. Oh well, it's gone up a bit because we were on 800 and something milliamps. But even so, even at that, it's pretty good for a dead short. Now, I did put some fresh electrolyte in this earlier on today, and I did measure the surface area, and the surface area isn't that piece of glass. It's actually 6 centimeters by 6 centimeters, so, or 6 by 7, something like that. So not bad really. See that? Yeah. Wow. 1.5 amps, that was on the carbon itself, as opposed to on here. Well, there you go. If I do that, we're talking 600 milliamps there. If I go straight to the carbon, 1.4 amps. That's incredible. What I'm going to do then is I'm going to put that back on charge for a few minutes and come back and touch the carbon again instead of this. I've obviously got a really, well, I've got a really poor connection there, to be honest. So yeah, a couple of minutes, I'll be back. I'm intrigued. Okay, that's had 4 or 5 minutes. I'm back on charge. We'll turn that off, and that's what we're looking at. I'm going to go direct to the carbon, not via this awful connection I've got there. 2.2 amps. Wow, that is incredible. I'm just going to do that again just to see if I was dreaming or not. 2 amps. Wow, that is absolutely incredible. Absolutely incredible. Now, because this is still drawing 140 milliamps there, I'm going to let that charge up a bit, get below 100 milliamps, and I'm going to come back and do that again. I am intrigued for such a small surface area. Right, so that's had a further 5 minutes. We're down to 80 milliamps on the current draw, and I'm going to try that again. Right, this is literally the following evening to everything you've seen about with this particular battery. I came in, turned the voltmeter on, and it there wasn't a lot in there, but it was about 0.8 of a volt, which was good in itself, I suppose, considering I'd actually discharged it. So I've just put it on charge literally as I've walked in, and now that's been on charge for about 10 minutes. And the first thing I'm going to do is do a short circuit test, because I was gobsmacked with the amount of power that this thing had on the short circuit. Now when I went to the titanium there's quite a dodgy connection, so I went to the graphite itself, you know, the graphite collector. So I'm going to do the same again. That's on the 10 amp scale obviously, and I'm going to go for a short circuit again now. Wow, 2.8 amps. oh, I've got to do that again, because I think I must have been dreaming. 2.5 amps. That is just incredible. Just incredible. So we must have some nice chemistry going on there now. I'm going to stick to that chemistry for a while. I know it's different to anything else I've done, and we know that it involves zinc sulphate. Okay, I'm still on with the same battery. This latest paper design, there it is, it's still there, haven't moved it. Short circuit test. Yesterday, it's 3 days old now, this. There's obviously no zinc dendrites or anything like that, as far as I'm aware. I've tested it at 250 milliamps, and now I'm testing it at 300 milliamps. Not expecting miracles, because it did 5.5 minutes at 250. But I just want to push the boat out as normal and see, you know, what it will do. It's quite powerful. Mm, 2.5 minutes then. And that ain't bad from a paper battery, which is 42 square centimetres. Okay, that's about 71 on a 3 amp short. That's about 71 milliamps per square centimetre. Not bad at all. Back on charge, I think. Right, just about one of the last things I wanted to show with this battery. I've upped the voltage from 3.2 to, well, 4.3. I meant to just put a volt on it. 550 milliamps current is being drawn at the moment. But I've purposely put a piece of glass on there as well, so I can see any outgassing through that microporous carbon. And there's a little bit of outgassing just there, and that's it. That's at 4.3 volts, and that's been on 4.3 volts now for about 5 minutes. So I just wanted to show that as well. So
fairly interesting then. Not what I expected. Didn't know what to expect actually. Zinc sulphate, half molar solution. So what was that discoloration then? Well, I've narrowed it down to this. Earlier on in the day, before I built this battery, I was trialling a new setup involving magnesium. A magnesium with a graphite collector on the cathode, with some new chemistry, and that was with it involved iodine. So it's a kind of a magnesium iodine battery. That's all to come in the future, that's not for today. But what I do normally with these graphite plates, once I've done an experiment, I'll take them into the wash area and wash the graphite plates. But obviously on this occasion, we'd still got some impregnation of iodine. It couldn't have been a lot, but it was there, and that's what that, obviously what that discoloration was, because I've seen that discoloration before when I've used iodine, that purple colour on the paper. So there's a bit of iodine in there somewhere, and we've got iodine ions playing a part as well as the zinc ions, sulphate ions, obviously chloride ions from the choline chloride. So we've got all sorts of ions zipping backwards and forwards there, and I guess until I sit down and try and do some work on the redox reaction itself, you know, with formulating the half reactions, and just to see what's going on, I won't really know. It was just a suck it and see moment, you know. You just I just tried it, that's all, and it works, and it works quite well. I'm quite surprised. So keeping it short, that's it. Don't forget your support if you can.